Moving on to relays, right? Relays are pretty simple. Here's one of the little black plastic ones that we had. I tried to show you guys in the shop. Everything we have has a sticker on the side of it, so it's going to show you the configuration of how this thing is put together and what it's intended for, right? But three things you have to remember when you're replacing a relay if you determine that it's bad. You have to know the coil voltage. If the coil voltage is rated for 24 volts, you want to put that back. Because if you put one that's got a 120 volt rating for the coil, your 24 volt power source will never apply enough power to close it. If you've got one that's rated at 120 and you flip-flop it, you put 24 volt coil in its place, that 120 volts is going to smoke your 24 volt coil. It'll work one time really good, really fast, and it's over. So coil voltage is very important. You have to know what coil voltage you are dealing with. Don't take it for granted like I've done in the past. You get complacent and you just think everything is 24 volts. It's not. Pay attention to the side. If you don't have a sticker that labels it clearly, call the manufacturer. Or pay attention to your wiring diagram. Follow your ins and outs and you can figure out what voltage it should be. So coil voltage, very important. The next thing you need to know is what type or how many, what type and how many of these switches that you have on there. You can have any combination of closed and open switches. There you could have one normally closed switch and one normally open switch. You can have two normally closed, two normally open, one normally closed, two normally open. It just depends, okay? So make sure that you know what type and how many switches you need. And lastly, make sure that you know the amp rating of those switches. If you choose a relay that's not heavy enough, relays are typically, light and medium duty anyway, but if you choose one that's not a high enough amp rating, then when the load that you power turns on, if it's just oversized for the relay, then it'll melt those switches inside, and it may melt the switch closed and always keep the load powered on, or it may burn it up and it'll never close again, right? So make sure that you know what your amp draw is. So I'll zoom in on this one, turn it upside down. There we go. And you can see here this is a Packard relay. There we go. You can see that the connections right here, 1 to 3, that is the signal or the symbol for our coil. We have a normally closed switch from 5 to 4 here, and a normally open switch from 2 to 4. If I wrote this out, I would say that 4 is my common, because it is used, when either switch is being utilized. But 2 to 4 would be my normally open switch. 5 to 4 would be my normally closed switch. You can see here on the side that if we use this for a 120 volt motor, we have, 14 amp rating for the switches. If we use this on a 250 volt setup, we've got an 8 amp. All right. Our coil here is 24 volts. So standard typical relay. You can see the, there we go, a little bit of light here. You can see the actual numbers identifying the terminals for the switches in here, and then your coil will be down here at the bottom. So pretty simple for a relay. Don't forget, we can use this. I didn't do it with the sequencer just a second ago, but if you were checking this guy, right, you could check. We've already identified that 4 to 5 should be normally closed and 2 to 4 should be normally open. Okay, we can come in here and we can check continuity. We can do continuity on 5 to 4. It beeps. 2 to 4 should not. And of course, this is with the power off, so it's not going to do as much good. We can't check it with the other side to make sure that it switched and reversed itself without turning the power on. But you can do several checks with the wires off and the powers off, right? We can do a reading on our coil to make sure our coil is complete. We can just set our meter to ohms and check out the rating for the coil. Make sure that it's not no resistance or open line, indicating a bad coil. So we have a good reading for our coil, and it should, if we put power on this, it should work.